Hi, everybody. Welcome to today's Tech Talk by USI with Resimac today. We're going to talk about rebuilding or replacing, specifically around pumps. We have Chris Mathson here from Resimac. Chris, you've been doing coatings for like 18 years, something like
I'll go
that?
with that. I'll go with 18. Yeah.
So lots of industry knowledge there. Thank you for joining us today, Chris, and thank you for everyone who's in our audience right now. Let's kick this off.
That's great. Yeah. So speaking specifically about pumps, right? Chris, you had mentioned that you've been getting a lot of inquiries, a lot of questions about pumps. Specifically, what is it that maybe some of your customers or some requests are coming in? Can you kind of give me an idea of what the
Yeah,
problem might be? Yeah.
So we're seeing a couple of things. One is, just typical erosive damage on the inside of the pump that needs to be repaired. It's someone says a 40 or a 50 or a 60-year-old pump that's just really hard to replace. And we're also seeing people that, when we talk to them and we say, hey, we have someone that can increase that fluid flow. Would that work for you here? They really like that too, because a little known fact is like 20% of all the energy used around the world is spent on moving water via pumps.
Yeah. It's crazy.
So that cost can get pretty high, and that coating actually tends to pay for itself pretty quickly in that process.
I mean, I don't know about you, Chris, but my it seems like my energy cost has only been going up, right? I mean, like my electric bill, holy smokes, right? I mean, I don't know what else I'm getting in addition to electricity, but it just continues to go up and up. And to, like you're saying, to take that factor into consideration, where most processed plants and chemical plants, whatever it is, right? A big portion of their monthly cost and budgeted expense is just in electricity using it, right? So if you think about pumps, any other type of process equipment that naturally, just like your car, just like any other, asset, after over time, it's going to start wearing down, it's going to start eroding, it's going to start losing efficiency, and it's going to cost more energy, more electricity to probably push and get the same or close to the same effectiveness or less than the effectiveness of the original offset to it. I think that the study that you're also mentioning or thinking about, it talks about over the lifespan of a pump or another asset. There's initial purchase and installation cost, obviously that everyone focuses on. It's easy. It's right at the beginning, but the maintenance over the life of that asset, if it's pulling it out of service, if it's repacking a pump, if it's doing all those maintenance aspects of it, eventually to the end of it, by the end of that life, right? By the end where it's considered, hey, this asset, this pump, this whatever needs to get replaced, that plant has potentially spent 7 times the original purchase price. All
Wow.
right. And it's crazy, right? It's crazy to think about, that is the larger, obviously much larger, exponentially larger expense is just keeping it in service. And by the time that it's at the end, it's probably less, like you said, lost flow, it's lost, head pressure, it's lost efficiency, all of that stuff. It's just gone. So those are the things that our material, we can talk about the what it is. Okay, it's coatings, it's paste grade, but the why is what we're talking about. Why is this something that somebody would be interested in looking at this? It's not
Yep.
only the replacement cost, right? But it's also the repiping. It's also the waiting the 6 months for the pump to even get on site because of crazy, long-term delays right now. Okay. All those other things. And then, of course, if you're trying to rebuild that 20-year-old pump, well, good luck because probably that pump manufacturer has stopped producing that impeller or that shaft or whatever that component is, maybe a while back. And it's going to be something that's going to be obsolete and not easily available. Okay. So those are the things that our materials can remedy, can fix, right? And so we talk about, the ability to bring back that OEM efficiency. How do we get that same asset working again, back up to par, and hopefully increase the flow, lower the energy cost, all those things, increase the wear resistance if it's an abrasive environment, that kind of thing. So I think that those are the things that you wanted to maybe touch base on, we can talk about today if you'd like.
Yeah. Just a couple slides here. Specifically for anyone who doesn't know, we're talking about like the Resimac 200 series is usually what's going to be used in these cases, right? And there's a bunch of products in there. We have a couple slides on here that will go over some of them. You can see on the screen right now, there's just, some really basics on what the system does and the different things that are provided there. And let's go to the next one. You have the 201, which is
Yeah.
kind of that repair paste, right? So when we're talking, cavitation, when we're talking eroded pump casings, really any damage on the inside where there's still a good amount of metal left, but you have pits or
Yeah.
cavities that are affecting your flow. This can go in, not just fix that flow a little bit, but also build back that area in the pump that you've kind of lost.
Yeah, that's it. I mean, if you think about it, traditionally, someone's going to go in there and probably weld in, fill in that void, fill in that pit. And those are important things because before you put a coating on, you need a kind of a uniform surface to coat on. You can't really coat over a divot. It's going to entrap air. It's going to have other issues, just in the application process. And of course, that's going to be a weak spot if you don't address it first. So those are the things. This is a cold weld, if you will, like a weld replacement, the paste grade. Okay, so it's a two-part epoxy. It has ceramic filler in it, and it's those are the things that it's designed to fill in the pitting, to rebuild, restore that worn metal surface back to a semi or completely uniformed finish, right? It's, surface prior to probably overcoating it with what you're going to show next is that ceramic fluid coat, the brushable coating. Yeah, so I mean that's it, and now you've got two layers, right? I mean it is possible, right? I mean a lot of guys will, a lot of what I want to say, a lot of shops will simply fill in the pitting because that's what they have the budget and the time to do this go. Okay, and that's fine. You can do that. But I mean, obviously, over time, it will also still wear, and it's going to probably wear the metal that we didn't fill, okay, over that period of time. But ideally, I think in most situations, and again, in that study that we were referencing back to, the study from 2006, they said, listen, if you're going to pull your pump in that example out of service to do service, right? If you're going to repack it, if you're going to do the maintenance, why not go those extra couple of steps to abrasively blast the surface, clean it up, fill in the pits, and then apply a two-part epoxy ceramic coating over top of it. And what they saw then was that efficiency gain that we're talking about. So that's what we're saying is that's kind of the system that has been in the market for a long time. And that is where we see the best bang for your buck, the best return on your investment, is in protecting and restoring that asset back to the performance, right, that you're looking for without the need of replacing, right?
Right.
Again, that's what we're trying to do is how do we put the Band-Aid on, right? But the Band-Aid that's going to stay on and provide that without the need to replace that asset. And so these are a couple of ways to do that.
Right. And so anyone who's interested in that study, I do have the full study I can send you. Put it in the chat if you'd like to see that. I took those slides out of here just because it didn't make for a great
Yeah,
like
it's a lot.
conversation topic. It's a lot of math and a lot of
It's a lot.
data, and it just made for a really hard like 10-minute presentation. I
Well, but
tried.
it is interesting to look at the study, and it is interesting to know and understand that, where it does cost a little bit of money to get to this point, right? The blue, the gray, it costs a little bit of extra money initially to get there. What they saw when they put that study out there and they did those 16, 19 different pumps and it left them running for a year, a couple of years, that right away the energy savings that they measured, right? This was a Northern New York Water Authority that did this study back in 2006. They said, wow, the return on our investment to do exactly what you're looking at there, the applying that brushable ceramic, the energy savings paid for that extra step in less than a year. In less than a year, it was already paid for. And then our life expectancy for this system is upwards of 15, 20 years before anything should be necessary to do, again, or to touch up.
I don't know how many things I've ever purchased that paid for themselves 20 times over.
Yeah, it's pretty great, right? Pretty great.
Yep. And another part of that system is the 203 Superflow, right? That's the one that gives you kind of the best fluid flow gain, right?
Right, right. So yeah, just like most of our systems, I mean, there's a right product for your application, right? So it's a matter of us asking the right questions and helping you understand, okay, this is what you're looking for. So where the previous line of the 202 maybe has a little bit more abrasion resistance, okay, this guy, right? A
Yep.
little bit more abrasion, sliding abrasion resistance. The 203 has a little bit more flowability, right? It levels out maybe just a little bit better than the 202 does, heightening the efficiency on being repellent, right? It repels the water. It's smoother than polished stainless steel, I say, right? And so it gives you that heightened efficiency, and it might be a little bit more cavitation resistant. So again, if that's your problem, if cavitation or is your issue, that might be the reason why we go to this one. However, both materials are amazing. They're pretty amazing, and both of them level out pretty remarkably. That's the feedback, and that's the what we see in the industry, right? Or in the
Yep.
applications. So
And
it's pretty great.
in these photos, you guys will see that there's kind of two layers. There's a gray layer and a blue layer, right? And we
Yeah,
typically suggest that you do that. So in this one, it was a gray layer and then that red layer,
sure.
which
Yeah.
looks a little orange. But the whole reason that we do that, for anyone who doesn't know, is you do the two-layer system so that you can kind of take a peek without opening the whole thing and say, all right, am I seeing any of that orange under the gray, or am I seeing any of that gray under the orange? That tells you it's time to reapply that coat. That way you
Right.
don't ever eat into that metal again. You're only eating through that coating that's going to give you that 20x return.
Absolutely. I'll say the other reason you do that is because during application, a lot of times we're in dark corners, dark areas, and so if you're trying to go light gray on light gray, good luck. It's hard. It's hard because it looks shiny. It looks like. So if you're going gray over red or gray over blue or blue over whatever it is, a little bit easier to know where you've been and where you need to go. And so all we're adding, this is important to mention as well, all that we're typically adding is 20 thou of an inch. Okay. So if we're talking about a jacuzzi pump, if we're talking about a swimming pool pump, a lot of times those clearances are pretty tight. But if you're talking about a water pump or a sewer pump or any of these other types of pumps, I mean, the clearances are pretty open. And so when you add 20 thou on that volute or 20 thou on that impeller, you usually have lots of room still in there, and it's not an issue. And hey, listen, if you want to add 30, if you want to do a third coat or a fourth coat, we're all about that. That's great. but but the recommended, or the normal application is only two 10 mil coats, or two coats to get you to 20 mil, 20 thou of an inch in total, and that's what we're typically looking at.
Right. All right. I'm going to stop sharing this. I'm going to open up microphones. If anyone has any questions, feel free to drop them in the chat now. I'm opening up microphones. You can also turn on your microphone and verbally ask those questions. It's kind of what we're here for, is to give you kind of a brief overview and then any specifics that you have. This is just a real brief touch on what the 200 series can do. Like Chris touched on a little bit earlier, we touched 3 products, but there's plenty in here that will cover, if you need a more chemically resistant material, if you need something that's going to handle some heavy abrasion, we have some great stuff for that too. And we got one here. It says, what types of pump failures or wear areas do you see most often where these repair products make the biggest impact?
Yeah. Well, again, typically, you want to go for it, Chris? Where do you see it?
Uh, um, I was going to say kind of what we showed, right?
Yeah.
It's in these big older pumps that have been running for um, oftentimes decades, that
Hmm.
just have that long-term erosion on the inside.
Yeah.
And they're super expensive and really hard to get replacements for. And oftentimes, one expense that some people don't talk about is the newer ones aren't the same shape or size. So what you're
Well,
replacing isn't
that
going to
that
fit
also might be though
exactly.
because it's more efficient and all that stuff. But you're absolutely right. Is that typically the wear is going to happen in the volute. I mean, it's where the fluid flow is going, right? And so if it's a sewer pump, I mean, hey, I've seen some remarkable things go through those sewer pumps, and that shouldn't go through the sewer pump. And they gouge the heck out of the volute. Water pumps, cut waters are completely gone. Where surfaces are completely gone. The shaft is being worn down. All of those areas that obviously have that flow constantly going, and if it's picking up any type of solids, any type of abrasive, then it's just basically like sandblasting the inside of your pump. And so over 10, 20 years, maybe it's 3 months in some of those sewer pumps. It can be honestly literally anywhere. So we've had, and I'm sure that Chris has shown these pictures on previous presentations where the volute, we got a hole right through the volute, right? A hole right through the vein of the impeller. And so typically, maybe somebody would look at that pump and say, well, that's garbage, that's trash. Yeah, with these products, with these materials, we're able to, patch, repair, fill in that hole, fill in that crack, repair that hole in the vein of the impeller, and then protect it with the brushable ceramic coating, and bring those back up and put those back into service, and boom, another 10 years, another whatever, years of service. And so it's pretty remarkable when it comes to that. Now, the reason why it might, kind of piggybacking on that question, the reason why it might abrade or wear or, erode in that area could be a lot of different reasons, obviously, right? It could be a solids, it could be a chemical, high temperature, something, something foreign. So those are the reasons that we ask those questions. Well, how long has it been in service? What is the typical service? Are we talking chemicals, high temperatures? And again, we have systems and materials like Chris was mentioning, different systems, different coatings, different paste grade materials, different paste grades that are filled with ceramic bead, all these different products potentially for those different applications. Just depends on what the application potentially is. Yeah.
And speaking of different applications, we have another question here that says, when you're looking at the 200 series in the field, how do you typically position 201 versus 202 versus 203, depending on the failure mode, especially
Yeah.
when you're dealing with erosion versus corrosion versus mechanical damage?
Well, easy answer between the 201 and the 202, they're different, right? 201 is a paste grade material. So think, repairing your car, it's a body filler, okay? It's the filling material. So if you have those gouges, if you have that pitting, if you have those cracks, easy. That's the filler material, okay?
Yep. So that's going to be your mechanical damage or, your erosion or corrosion damage,
Absolutely. Yeah.
right?
Deep, deep crevicing, right? We need to rebuild. So you can't rebuild with a coating easily. You're gonna be there for a minute. So yeah, you're rebuilding with the 201 paste grade. Okay. So we'll go with that. Okay. So that's the easy answer for the 201. The 202, the 203, again, it's going to be what is your end result? What's the desired end result? Is it more a sliding abrasion concern, or is it we want to enhance the flow? We want to, be more cavitation resistant. And I would say that those are probably between those two specific coatings, the reasons why I would go from 202 to 203 or vice versa.
Here's a question that I just thought about when we're talking about high temperature.
Yeah,
We have that new 101 HT product, right, which is a high temperature
exactly.
version of our regular metal repair.
Sure.
I is there, and this is kind of putting you on the spot, is there like a
No, it's okay.
201 HT in
Yes.
development?
Yeah. Well, I'm sorry. The 207 XHT pace grade is the 101 XHT. So we have it.
Oh, okay. So that
Yeah.
that
So think about it this way, right? So our pace grade materials, if it's the 201 because it has the ceramic, or the 101 because it's fully machinable, all right. But if you or somebody comes, Chris, and says, listen, but this particular pump or this particular process equipment, it's operating at 300 degrees Fahrenheit, full immersion. And we say, okay, well, that's not going to be suitable for these other paste grade materials, but the filler material, okay, that paste grade material in that particular case potentially could be that 101 XHT. So I need a plate bond, I need to fill in the voids, whatever that is. 101 XHT, 101 XHT will be the paste grade for that application. And then again, 202, 203 that we've been talking about, great for pumps, great for normal operating temperatures. However, again, you tell me, yeah, but this stripper, this whatever, this other asset, it's operating at elevated temperatures, 350, 300 degrees, 200 degrees. Oh, well, that in this particular case, we're going to go to that brushable ceramic coating that's suitable for high temperature, and that's going to be that 207 in that particular case.
Right.
Yeah.
We got another question, which is, what's the biggest mistake you see people make when applying the 200 series that ends up hurting performance?
Yeah, I would say honestly, and this is a good one, surface prep,
It's
right? I
always
mean,
surface prep.
the nice thing is, yeah, it's got to be it, right? Because, we always try to take corners, get it back into service as quickly as possible. Also, maybe not allowing it to cure long enough. Um, we know, I listen, I get it. Downtime is money lost. And we can be talking about lots of money lost. And so, yes, we definitely want to get that back into service as quickly as possible. Tell us that. Listen, this just has to hang in there for a couple more months until we get to a shutdown because we probably have a material that would be better suited for that. Okay, if you need that fast turnaround, but you know, again, if we can, if you want that 10-year, 15-year, 20-year service life, we got to do the steps. We got to do it, right? So that's going to be an abrasive blast. That's going to be, maybe beveling the sharp edges, right? All those spots where, just historically, coatings are going to fail here. Coatings are going to fail because of this, and that's because we try to hurry up. Okay, so yeah, that's it. And listen, each of our coatings, each of our materials, they have a technical data sheet. They go step by step, and it says, for best results, here's what we want. Here's what we recommend. Boom, boom, boom. Do it this way. And then of course you've got you, Chris. We got me, Chris. There's other resources that that end user can fall back on and provide that technical support and that best practice know-how, and that's what we would encourage you to do. But I would say, if anything, it's going to be that it's going to be surface prep or the lack of, and yeah, and using the wrong material. I'm going to say that as well, right? Maybe they said, hey, I did this on the last one. Well, this one might not be the same as the last one, so don't just assume that because we used it here, it's going to be used here. So again, let's ask the questions and make sure that we have the right material going on to this application.
I actually have a prime example of that with a client who it was a waste pump, and where it was pumping from was it was kept hot. I forget exactly why.
Okay.
We had sold the materials to it was actually the 300 series, so 301 and 302,
Right.
to repair part of the pipe along the way. Well, they
Okay.
used that at the beginning of the pipe. Well,
Yeah.
the flare temperature at the beginning of the pipe was a lot higher than the flare, like extreme temperature in the middle of the pipe.
Okay.
So it actually it didn't quite fail, but it didn't do exactly what they expected it to.
Yeah.
And I
Well,
believe we ended up
yeah.
selling them some 101 XHT in that
Well,
application.
makes sense, right? Makes sense.
Uh, because it was just a couple of pinholes in the sewage pipe, and they're like, "Hey, this is scheduled to be replaced in, I think it was 2 years. So like, we just
Yeah.
need something that'll stop it from leaking today."
And guess what? They're gonna get to the 2-year stop. They're gonna get there and it's gonna be fine. They're gonna say,
Yeah,
well, I guess we can leave it another 2 years. But that's exactly it, right? In other words, it's not a failure. It's just you went beyond the limitations of that particular material. And so those are the reasons we ask the questions. We want to make sure that we're leading that end user, that contractor, in the right direction, and say, listen, this is the limitation. Okay, at this point, it's going to get so soft that it's not going to work, or whatever that is, or it's never going to cure. I've got guys in Canada call me, hey, it's -20 up here. Can we apply it? Well, good. You can apply it. It's just never going to cure. It's not going to work. And so, but there's tricks. I've done it. I've applied coding at -20. You just have to do it a different way, right? So let's walk through how to make that successful. Yeah.
yep. All right, we're a little past time, so I'm gonna do one more question, then we'll wrap up. We had another one saying, "How realistic are these repairs to perform in the field versus in a shop environment?"
Yeah, well, obviously in a field it's going to be more difficult, right? Because you're limited. You got, ambient temperatures are different potentially, right? And everything else. But can it be done? 100%, absolutely, right? And so, again, just give us an idea of what your limitations are, where you are. If you're, down in a sump versus, someplace where we can, warm it up and all that kind of stuff, and we'll make our best recommendation on that particular application and try to make it as successful as possible for us.
All right. If anyone has any more questions, feel free to reach out after this. You should have my email, or you can. The chat for this and the Q&A, I think, stays open a day or two after, so you can put any more questions in there. Chris, thank you for presenting with us today,
Thank you.
and thank you everyone who joined our tech talk. You can always get a hold of us at usigroups.com or reach out via phone at 248-348-3802. Thanks
Thanks,
again,
Chris.
everyone.
Thank
Thanks,
you, guys.
Chris's.
Thanks, Chris.
Thank you.